Hey, so today we're going to talk about clock reactions. And what a clock reaction is that it measures the average rate during the first part of a reaction. The shorter the time period over an average rate is measured, then the less the rate changes over that period. So an example of the clock reaction that I'm going to do today is the iodine clock reaction, the vitamin C version. So what I'm going to be doing is taking the aqueous iodine, which is originally colored in orange-brown. And the time from the start of the reaction, the appearance of the iodine color is going to be measured by the end. So what I did was I created two solutions, solution A and B. Solution A is a mixture of the iodine and crushed vitamin C pills. So that's this mixture right here. And that when those two are mixed together, it forms a colorless mixture where the iodine is used up by the vitamin C and it creates iodide, which is I-. So the I- and the vitamin C ions are mixed together. They're creating that colorless solution. Then I have solution B, which is a mixture of hydrogen peroxide and starch. That's solution B. Now you take these two mixtures and you put them together, and when it's two reactions that are occurring at the same time, so the reaction actually occurs very quickly. What's happening is the hydrogen peroxide wants the I- to go back to I2. So the iodide wants to go back to iodine. But instead, the vitamin C is causing that I2 to remain as an I-. So due to that, with the hydrogen peroxide, ends up using up that vitamin C. Once that vitamin C is used up, then the starch that was in the solution B, the starch forms a complex with the iodine, and this is where we create this blue-black color solution that I have right here. So some different things that can affect this can be temperature or the increased amount of vitamin C. So if you have a really high temperature, it's going to take a shorter amount of time for this solution to occur. Or if you have a really cold temperature, it's going to take even longer for the reaction to occur. If you have an increased amount of vitamin C, it's going to take a lot longer for the color to change because there's a lot more vitamin C that needs to be used up. So I have some leftovers of the solution. So I'm going to go ahead and do this one more time so we can see the reaction change. So I'm going to take equal parts of solution A So I'm going to take solution A and put it in the cup. And then equal parts of solution B. Okay. And add that to the cup as well. We should just fill the cup just about right. Okay. So when we add those two together, we get a new spoon. The solution, we can then mix them together, and it might take a couple minutes. Well, not really a couple minutes, it might take a couple seconds when the reaction starts to change, and the whole cup will change at the same time. Now when I used it, it changed pretty quickly for me because the temperature of the water was a lot, there it goes. Temperature of the water was a lot hotter. But as you can see, there's the solution after when equal parts are mixed together, creating that black-blue color based on the mixture. So that's the iodine clock reaction. I hope you like it. Thanks.